So, first off, can you give me a reason that f of n doesn't belong?
It's the only one with the two in the front.
Okay, on your paper, there are parentheses. Is there parentheses for h of n though? Okay, so can you be more specific? I kind of see where your thought is going. But it's the only one with the two that is what? Okay, but like. What do we call it, the position that the two is in right now? Not A. B, which stands for what? Okay, so you could revise that thinking. You could say it is the only one with two as a common factor. All right, now what you said was not wrong. Just these usually help us with our math vocabulary. We want to attach it to things that we've learned and reviewed. But I agree, it's the only one with two as a common factor. Table 8, give me a reason why g of n doesn't belong.
It's the only one with eight as a common factor.
Only one with 8 as a common factor. Not wrong. Can someone else give me another reason why it doesn't belong? No one else in the class? Yeah. Do you have another reason why it doesn't belong other than about the 8? Yeah. See you then. Why else doesn't it belong? Am I like, oh, okay, because it's a G, not an F.
It's gonna increase the fastest.
It does increase the fastest. Something else that I think is a bit more obvious. Justina?
The initial one is the
The initial amount is 2. And all the other ones, the initial amount is 8. What else do we call the initial amount? Like math vocab? The initial amount is always what on your graph? Y-intercept, good. So you could say initial amount is 2, y-intercept is 2, where all the other ones, the y-intercept is 8. Okay, good. Now, table 1, h of n. Why is h of n not belonging? It doesn't have a power of n. No power of n. No exponent. Earlier, someone said it's the only one with addition in it. That's true. What type of function does h of n represent? Linear. So it's also our only linear example. It still has a y-intercept of 8. It still has a common difference of 2, but it's not a common factor when it's linear. Okay, so the common difference is 2. But yeah, in other words, it's the only one that's linear. So then table 2, give me a reason that j of n doesn't belong. Only one with a fraction. On Friday, we learned what that means when the b is what, it's what type of function. How should I expect this graph of j of n to look? Will it be increasing? Will it be decreasing? And it's going to be also the only one that decreases, so that could be another reason that it doesn't belong. Only one that decreases. And then to be even more specific, it's the only one that's exponential decay. All right, the others are all growing. This one's linear, but it's still growing. This one is decaying, and it's because that b value is less than one. Not just that it's a fraction, that it's a fraction smaller than one. Okay, but good warm up. So just practicing attaching it to things we've learned, right? I know you guys can tell the difference between things. Now just attach it with those vocab words. Today we're on lesson 13. It's the same title as lesson 12, just now it's part 2. So specifically today, we are going to investigate what we can learn from graphs that represent exponential functions, what it means when they intersect, and when you know 2 points, not necessarily 2 points right next to each other, how to make the equation set. That's what we're going to try to cover today. If there's no puzzle piece of lesson 13. I'm on the wrong slide, Joe, but anyway. All right, puzzle piece of lesson 13. Your next quiz is Thursday. So lesson 8 through lesson 15 is what it'll cover, but that's your next quiz. Next week is unit test week. So, you know, if you've been behind on your homework, start getting caught up. The deadline, the final deadline is coming soon. And plus that's good practice for your assessments. All right, now today's activity so that we can hopefully meet our learning targets. We have a graph representing an exponential function f. The function f gives the value of a computer in dollars as a function of time x measured in years since the time of purchase. Side note, we've talked about before, function of, whatever follows that phrase, function of is always your x. So you see how this graph isn't labeled? You could go back and read it since it says function of time x. That needs to go on my x-axis. And it's years since the time of purchase. That's a weird S, but you guys get the point. So time, the x-axis is measured in years since purchase. You're going to use this graph to answer A through F. Some of it's review, some of it is new, but we're going to see if you can still figure out, you know, when the coordinates aren't right next to each other, what's my factor, what's my value, things like that. So try that out, however you want to do it, divide and conquer, if you all want to try it and then compare answers. But in your groups, I'm going to give you 5 minutes before we start sharing. So table 4, what is the purchase price of the computer? $400. And where did you look for that information on the graph? What do we call that part of the graph? Y-intercept, good. So y-intercept is like what we math people call it, but then in like the real life situation, it's our starting amount. So yeah, that must be what the purchase price was because that's where time is 0. So that's another indicator. Whenever your x is 0, that's your starting amount. So that must be the value of it when it is off. So then table 5, what's the value of f when x is 1? 200, and that's not labeled, so how'd you get that? Oh, like visually, or did you like do math? Like, okay, so visually would work for this graph. I think on your homework, it wouldn't work that well, so I'm gonna teach you another way to figure it out too. But yeah, if you have a graph that's easy to estimate, by all means. In between 0 and 2 would be where the 1 is on the x. See where it touches on your graph? It looks like it's touching at about 200, right? So that's reasonable to say f of 1 equals 200. So table 8, can you tell me what the meaning of f of 1 is?
1 year after computer purchase.
Okay, so that covers the 1 part of it. We know that f of 1 equals 200, so can you incorporate the 200?
It would be $200 1 year after the computer.
Okay, good. So value was $200 1 year after purchase. You have to talk about both parts, like, because F of 1, when I asked you what's the answer for F of 1 is 200, so like you have to talk about the 100, or sorry, you have to talk about the 200 and the 1. What does each represent? If you get confused, well, 1 is the X, X is for time and years since purchase. 200 is the Y, which would be like our value. So talk about both when we interpret. Now, table 1, that's a weird sentence. I don't know if it's as weird on your paper, but how is the value of the computer changing each year? Good, decreasing. I would put by factor of 1/2, because that does happen to be what we are multiplying by each time. You could also just say it's halving each time. I like the number 1/2 because when you say it's losing a half, and you plug it into the 1 minus 1/2, what's 1 minus 1/2? So it doesn't trick students as much because it still ends up being 3 times by 1/2. But if it said that it was losing like 1/4 of its value, then what it's timesing by is 3/4. So like, just remember that difference. If it's losing something, you do the 1 minus whatever it's losing. Your common factor is multiply what you're keeping. Okay? So decreasing by a factor of 1/2. That's a good explanation. Now we need an equation that defines F. So table 2, what would that equation be?
Would it be, I think like 100.
And X like this?
Yeah.
Okay. I mean, I want you to be more specific and the area a little bit better. But yeah, raised to the power of X. You don't want to confuse it with Y equals MX plus B or anything. It's an exponential function, so the variable should be the exponent. Also, I just revised this to be F of X, just for our function equation. But yeah, good on that. 1/2 is equivalent, 0.5. So then whether the value of F will reach 0 after 10 years. So whoever spoke for your group last, try to keep yourself quiet this time. Table 4. Whether the value will reach 0 after 10 years. Do you think it will? Okay. So if that's true, then I should be able to, if it's 10 years after purchase, I should be able to plug in 10 for the exponent, and then it should give me 0 if that's true. Or maybe even a negative, but we'll see. We'll compute that right now. All right, so 400 times 0.5 to the 10th power. Is that 0? If we round it to look like money, because we're talking about value of something, how much money would it be worth? Like 39 cents. That's still something. So technically the answer is no. If you were looking at the graph, I could see how you think that. But technically the answer is no when we do the plugging into the formula. So you could say no. It is worth 0.39, which is not 0. Okay, let me make that look more like the word worth. But yes. So good exercise. The next problem, number 2, is going to be kind of like your check for understanding from this exercise. So you're going to try that next. So we have graphs of 2 exponential functions. For each, you're going to come up with the equation for that graph and the value of the function when x is 5. So try number 2. I think we'll have enough time to cover it today. So I say. I give you 4 minutes to come up with the equation and evaluate it for when x is 5.
So remember, those of you that already spoke, try to contain yourself for this round.
Table 5. Did you come up with the equation for the first graph? Okay, so let's see if that's true. This does look like an exponential function. It also told us it was an exponential function in the description, because you can't always assume. So that means it should follow this format, a times b to the x. So the way that they listed it, 5 is my a stands for what? Okay, you're both right, initial amount. Is this the initial amount of my graph? Yes, if you were confused because it also extends into the negatives, that's all right. We've seen where the t value is negative, but we know that when t is 0, that's when the times start. Right, so like anytime x is 0, or on your y-axis, in other words, that's your starting amount, it should be 5. The 3 is your common factor. It's what I'm having to multiply by each time. So, and when I say that, I'm really just referring to the y's. We're multiplying the y's each time. They do happen to give us coordinates that are near each other, so that's nice. So I'm just organizing it in a table because sometimes it's easier to read from a table. Is 5 times 3, 15? Is 15 times 3, 45? So then b is 3, because that's what we're timesing by each time to get to the next number. If that's hard for you to figure out, sometimes the numbers are not that nice. Take one of the values and divide it by its previous value. That'll always give you what you have to multiply by. Get there. Like working backwards. Good on this one? All right. Table 8, do we have the equation for the second one? Or using this one as a model, maybe? Can we come up with this one? Okay, well, let's use it as a model. Is this one also exponential? Okay, so then it should also follow this format. Let's call it g of x for fun. What's my a gonna be based on this graph? Table 8. 20. That is correct, because that's my starting amount, right? That's when t is 0. So good. What am I having to multiply the y's by each time to get to the next number? If you're stuck, maybe consider making a table. Okay, Riley says 0.5, let's see. Note that they skipped, or no, they didn't skip right here. -1 is right next to 0. They skipped 1. So if it helps to fill in the 1 and see if it still follows the pattern, go ahead. But 40 times 0.5, is that 20? So half of 40 is 20. What's half of 20? And then what's half of 10? So that is the pattern. So yes, this can be 0.5 or 1/2 to the x power, because we're talking about exponential functions. The last part, which I don't know if we'll have time to fully cover, we can try. 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of 10 to the x. So 1/2 to the x power of is to evaluate it when X is 5. If you're using function notation, the left side is just notation. The right side is what you put in your calculator. Preferably all at once, or if you break it apart, make sure you do exponents first. Exponents come before multiplying. Does anyone have answers ready, or
Yeah,
what's f of 5?
1, 2, 1.
What's g of 5? 0.65? Okay. You guys are the first class to get this far, so I will check, but, you know, if you use a calculator, it should be right.
All right, don't lose your notes.